So, sorry, my board is not working, so I'm not going to be able to write on it. We'll have to use Sphere and look at it all by paper. That's okay, because that's what you have. So, we are on lesson 1.3 for today, which is prime factorization. Now, our goal is that I will write a number as a product of a prime factors and represent the product using exponents. I'm going to open up my OneNote because this has... Actually, I'm going to stop there real quick. Now, remember, I always said that that's our learning goal. That's what we're saying we're going to be able to do today. But we have to know what that means. So when it says, I will write a number as a product of prime numbers and factorizations. On your notes, if you want to go in here and say... do that, or I might even grab the highlighter out of your basket and say product of prime factors. On your homework, that's the question that's really messing people up. They're not getting that. Remember, what does the word product mean? What's that vocabulary mean?
The answer to a multiplication.
Okay, so it's the answer of multiplication. So I will write a number as a product. So I'm going to write a multiplication problem out. It then says of prime factors. Does anyone remember what a prime number is?
Prime number is a number that can be multiplied by 1 itself.
Good. Prime numbers are numbers that the only factors are 1 in itself. I'm going to write up on the board. Our prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 31, 37, and there's some more, but we're going to stop there. It goes on forever. It just, the bigger the number, the more spread out they are. Why is 2? Why did I put a star by 2? Does anyone know? It's the only even number. All other even numbers can be divided by 2. So 2 is the only one because it's being divided by 2. Well, that's its number itself. So what we're going to do is we're going to take a number, and let's write this down right here by your I can statement so you understand it. Let's write down the number 12. Oh, did I hand it out to you? Thank you. I'm trying to make it tough for you. Alright, so we write down the number 12, and this is your goal today, is that you can take the number 12 and write it as a product of prime factors. So I'm not just going to have you guess what numbers we use up there. Okay, I'm going to do 7 times. No. What you're going to do, and I'm not going to explain all this yet. I'm just going to have you copy it. But you will show that you will do this. Okay? So I want you just to copy that part down for me right now. We'll go back and we'll make sure you understand what it means here in just a second. Okay, everyone almost have that? Alright. I'm going to pull open my OneNote. Get to the right class, that'd be fantastic. Alright, lesson 1.3. The reason I'm going through this is just because I know I can't write on my smart board because it's broken this morning, but I love this part over here. Remember, this is how we are going to prove we can do our goal. So, I can find factor pairs of numbers. We're going to work on today and identify what factor pairs are, and once you understand what those are, it's really, really easy. We're going to explain what prime and composite is. Well, thank you. We already identified prime. We could already take care of this one. What would be a composite? If prime numbers are numbers that only are divisible by 1 in itself, what would be a composite number, Grace?
A number that is
You're right there. A number you can divide by multiple numbers, more than 1 in itself. 6, for example, is a composite number because I can do 1 divided by 6 or 2 times 3. So it has more than 2 factors is mainly what you say. Besides 1 in itself, there's another factor that goes into it. I can create a factor tree to find the prime factorization, and then I can write the prime factorization. These last two really go together. I do the factor tree to write my prime factorization. Alright, I can't click on my board. Oh my gosh, this is driving me nuts. Okay, so here's what we're going to do first. Open your workbooks for me, please, to 1.3. Okay, here's where we are going to work with our partners, people at our table groups. We have our learning target. We have our success criteria. Here's your exploration. I'm going to explain just a piece of it, and I want to see if you guys can figure this out. It says, work with a partner, which is going to be your entire table group. 2 students use factor trees. So remember, if you use instructions to help you, I can tell these are factor trees. So if I don't know what a factor tree is, I'm saying, okay, well, if that's a factor tree, what are they doing? What is a factor tree then? Try and see if you can figure it out. To write 108 as a product of factors. There's that word again. Your homework is going to ask you for the product of factors. Student A said 108. They broke it into 2 times 54. Because 2 times 54 is 108. So instead of saying 108, they said 2 times 54. They then broke 54 into 2 times 27. So they said the product of factor of 108 is 2 times 2 times 27. They wrote that with 3 factors. Remember, a factor is a number of multiplication. If I use my calculator and said 2 times 2 times 27, you get 108. Notice that they did a factor tree. They didn't just randomly guess numbers and say, oh, I'm going to do 23 now. They had a method. Student B said, 3 factors. Yeah, I'll do it in 4. So they broke it from, instead of 2 times 54, they said 3 times 36. 3 times 36 is 108. Then they took 36 and made it 3 times 12, because 3 times 12 is 36. They took 12 and made it 2 times 6. So then they said, I have 3 times 3 times 2 times 6. And that would equal 108. They are correct. And they did it with 4 factors. Your job on A, you may not use 1 as a factor. Can you write 108 as a product with more factors than each student? I'm going to give you that. Yes, you can. Here's the competition. First table group to show me a factor tree breaking 108 down to 5 factors, and everyone in your group understands how a factor tree works, wins the links box. Okay? Remember, this is not just work on your own. You may talk as much as you need. If you don't understand it, listen to someone that is understanding. Okay, ready, begin. We're coming back together. Let's talk about this. So before I start breaking this down, a couple groups got it. When I look at these numbers, and I'm going to go ahead, I can't write it in his notebook, and mine's already been filled out, so I'm going to copy it here on paper. They broke 108 into 2 times 54. Now, why did they not break the number 2 down? Grayson? 2's prime. So here's a hint. If you get to a prime number, we circle it. You remember I told you that we are working on writing the prime factorization? So we want to break every number all the way down till we get to a prime number. 2 is prime. Is 54 a prime number? No, it is composite. So if we have a composite number, we want to break it down. Well, student A said, okay, well 54, it's prime, or it's not prime, it's composite because 1 times 54 is 54, or I could do 2 times 27. Well, 2 is prime, so I'm going to box it in. I'm done with it. And student A stopped and said 27 is prime. So they wrote their answer as 2 times 2 times 27. However, is 27 a prime number?
No, it's composite.
It's composite number. What else could I break 27 into? Grace?
3 times 9.
So I could write it as 3 times 9. Is 3 prime or composite? Prime. Is 9 prime or composite?
Composite.
Oh, if it's composite, I'm going to break it down. 9 can become what? 3 times 3. Now, I don't have anything else to break down because I have boxes around every branch. So I can't branch out anymore. So when I write it down, I go by my smallest number first. 2 and 2. So 2 times 2 times 3 times 3 times 3. This is what you would call the product of prime factorization. It's a product because it's multiplication, and we use only prime numbers. For a couple bonus points, we'll say coolness points, 5 coolness points, is there another way I could write this 2 times 2 times 3 times 3 times 3 if I was being my mathematician lazy and I don't like doing a lot of writing?
You just do.
Yeah, you remember how we did that very first lesson? 2 is being repeated, so it becomes my base, all about my base. And there's 2 of them, so 2 to the second power times 3 to what? Third. I will tell you, your homework tonight, it's wanting you to write this first one, though. They're asking you to write it out this way. So, the only way to get 108 and write it down as prime factorization and get the answer of 2 times 2 times 3 times 3 times 3 is the way we just did it, correct?
On our homework, will we break down the little branch?
No, you'll write this part.
Okay.
So is this the only way to get the answer?
No.
I don't believe you. I think you're lying to me. Are you sure?
Yeah.
But I got the answer. And I'm telling you as a teacher, this one is correct.
But there's more ways to get the same answer.
What do you mean? What did you break 108 into?
3 times 36.
Whoa. Now I did 2 times 54. You're doing 3 times 36. Is that okay to do, guys? Yeah. 108's composite. There's more factors, so 3 times 36 is 108. Is 3 or 36 prime?
3 is fine.
So I'm going to box that around. Well, I don't know if I can feel comfortable. You have a 3 prime and I have a 2, but I'll go with you for now. Okay, 36 you said is composite. So what could I make that into?
3 times 12.
Okay, 3 we've already identified as prime. Is 12 prime or composite?
Composite.
Okay, so if I have a composite number, I have to break it up.
And 2 times 6.
2 times 6. 2 is prime. Oh, well, that's what student B did in our notebook.
Yeah.
Okay, so then he...
No.
What?
Then you break 6 down.
Oh, so student B stopped at 6. But since 6 is actually a composite, 6 can become what?
3 times 2.
3 times 2. 2 is prime. 3 is prime. So, if I do this again, there's 2 and 2. 2 times 2. 1, 2, 3 threes. 1, 2, 3. We get the exact same answer. Okay, smarties. I don't trust you. I'm going to give you guys a couple more minutes. Can you find another way to find the exact same answer? You can work with a partner, or you can work by yourself. Not yet. That worked out a little. You got one? What? That was like super fast. Alright, let's pay attention. Let's check her. What do you got?
So I broke 108 down into 4 times 27.
4. Wow, she used a totally different one. Times 27. 4 times 27 is 108, so we're okay. Is 4 prime or composite?
It's composite, so I broke it down into 2 times 2.
Okay, 2 times 2. And the 2's are prime.
And then I went back to the 27 and I broke it down into 3 times 9.
3 times 9.
You circle the 3 because it's prime.
3, in case you can't hear it, 3 is prime, she said.
I broke 9 down into 3 times 3, and then you circle both 3.
Okay, and let's check her answer. She has 2 2's. 2 times 2. And she had 3 3's. Exact same answer. Now, I'm sure you guys found another one. But I'm going to stop there for real quick. Here is why this whole method is awesome. You can use your strengths with math to go through any way you want. The biggest thing is every time you get a factor, you have to ask yourself, is it prime or composite? If it's a prime number, you circle it and you are done with it. If it's composite, you break it down to one of the other factors. Now, here's a trick. We're already going to skip ahead and work on one of our things. Remember I told you one of the terms we had were factor pairs? What if I told you 2 and 54 were factor pairs? 2 and 27 are factor pairs. 3 and 9. 3 and 3. 2 times 2. 3 times 3. 3 times 36. Those are factor pairs. If you think of the name, what do you think a factor pair is? Turn and talk to your neighbor real quick. That way, even if you don't know, you can say what your partner said. What do you think a factor pair is? Hey, what's up? I know. So I have it shut off for now.
Oh, you do?
Yeah. Alright, real quick. What do you think a factor pair is?
So it's a number that gets broken down. Or no, it's the number that has. It's the answer to the prime number that you want to, or no. And then 108 divided by 54. You break that down, so it's a pair because it's pairing together to equal 10. It's those numbers that are highlighted, the number above that, they can times together and equal.
Yeah, see that it's doing that square thing.
Oh, that's fun.
Sure.
Later.
After this block, I'm done with it till fourth block.
Okay.
Thank you. All right. So let's explain factor pairs this way. I go to Dick's Sporting Goods, and I want to buy some shoes. So I buy one shoe. No, I buy what? I buy, what do they call it? A pair of shoes, right? So when what did you say? Yeah. So I buy a pair of shoes, right? And the pair of shoes, they go together to give me one set that would fit both my feet, right? So this is, so if I go in there, I have his shoe, and I have my shoe. Is this a pair of shoes then?
No.
Would Dick's Sporting Goods give me this? I go in there and I'm like, I need some new tennis shoes. And so now I get the two of these, right? Smells fresh, doesn't it? Oh, I think he just threw up in his mouth. God. So, is this a pair of shoes?
No.
No, it's not going to work. Why? Why will this not work as a pair of shoes? Why can I not go to Dick's Sporting Goods and say, I want a pair of shoes? I got my shoe and I have his shoe. Why can't I get these two in a box together? Shay?
They're two shoes, but they're not two of the same shoe.
Oh my gosh, I love how you said that. They're two shoes, but what?
They're not two of the same shoe.
Okay, they don't give me what I need, right? When we worked with factor pairs, we identified what factors are. Factors are numbers that are multiplied. If I scroll down here and I see my factor pairs, well, let's say I'm trying to get to the number 12. Okay, I can list factors. 4 and 8. 4 is a factor. 8's a factor. So are 4 and 8 factor pairs of 12?
No.
Why not?
Because, the product for 1 isn't 12, it's 32. And if you were to break it down like we did on the other ones, then 12 would be 2 times 6.
Okay. So, just like this, 4 and 8 cannot be factor pairs of 12. 4 and 8 are not factor pairs of 12. Just like when I try to buy a pair of shoes for me, Dick's Sporting Goods will not give me one of my shoes and one of Andrew's shoes because they didn't go together to give Mr. Sissel shoes. So on here, these are not going to be factor pairs. Can anyone tell me what would be factor pairs of 12? Grace? Okay, I could say 3 and 4. They are both factors, and if I pair them together, they give me my given number. Right now, my given number is 12. So one of the factor pairs of 12 is 3 times 4.
2 times 6.
2 times 6 are factor pairs. Yep.
12 times 1.
And 12 times 1. These are factor pairs. Factor pairs are just numbers that go together to give you a set given number. Okay? So, let's close our workbooks. Let's put them to the side. We'll put them away after a while when it's work time. And let's look at our notes together. The notes really should not take us too long. In fact, I want to get through them in about the next 20 minutes so you can work the last 20 minutes in class. The first thing I want you to make sure you do in your notes so we make sure we don't lose them is write our name. This is first block silver. And today is September 3rd. In 6 days is my dad's birthday. Maybe I'll bring cupcakes in.
In 15 days is tomorrow.
It is not, don't lie.
Yeah, it is.
Oh, really? Okay, I believe you. What did I get all over my desk? I just got all over my hand. Okay. So, how do you think we can identify what a factor pair is? What do you think? I'm going to write it down. Two numbers multiplied together for a given number. Pretty close to what you said. I know it wasn't exact, but that's just because my memory isn't as great. Yes, Grace?
There's also two factors multiply together to find the composite.
Awesome. And if that's what you want to write, that's perfectly okay. Remember, your definition can be just a little bit different than mine. Okay? So, factor pair. Two pairs multiplied together, or two numbers multiplied together for a given number. Or if you want to use more math vocabulary, two factors multiplied together to give you a given product. Alright, so this shouldn't take long on this part. Our first example is just finding factor pairs. It said the brass section of a marching band has 30 members. The band director arranges the brass sections in rows. Each row has the same number of members. How many possible arrangements are there? To be honest, whenever I work with a story problem, I underline the important information. Everything else is fluff. Now, I'm going to give you guys a huge hint. Maybe your other teachers never told you because, I don't know, they're not as cool as I am. Or good looking or thin. Now, when we get to story problems in math, we always talk about making things like relevant to students, representing every race, every gender, every religion. It's hard to do that in math because math is numbers. Numbers don't have that kind of connection. So the way we do that is they write story problems. They change people's names from Bob to Ariel to other names. Or they say instead of Ross in Shipley, Nebraska, they'll be like Zaire in Africa was, or Cindy in St. Louis was working with, and they change the stories to make them more referenceable. It's great. It shows that, but to me in math is numbers. So all that, what they're trying to do is kind of the fluff. And I think that's where students get lost in story problems. If I've asked any student, they always said the hardest part of math, the part they struggle with the most is story problems. They don't get what to do. So this is where we underline. When it says the brass section of a marching band has 30 members, do I care? I don't care what it is. They have 30 of something. That's all I need to know. I underline 30 members. So in my head, I'm thinking 30. There's 30 of them. The band director arranged them in rows. Good for him. Each row has the same number of members. Ooh, that part's important. Because each row, same number. That tells me we have an array. We're doing division or multiplication. How many arrangements? That's all I really need. This whole paragraph. I just need 30 members, each row, same number, how many arrangements. That's all I need to know. So, when we break this up, the way we'll do this is using factor pairs. They identified the factor pairs of 30. Now, you're going to be asked on your homework tonight, identify the factor pairs of this number. They're going to give you a list, and you're going to click on each one that's a factor pair. Remember, just like Andrew and I, all we have to do for this is say, do these two numbers go together to give us the given number? Or is it Andrew's shoes and Mr. Shoes? That's a lot of S's I was trying to do it. Or is it like Mr. Sissel's shoe? We put Andrew's and mine together and it gives us like clown feet. It just doesn't work. I'm going to show you a trick on how we can find all factor pairs. So right here in your notes, I'm going to turn mine sideways to give me room. Let's write down the number 30. Okay, this is my trick that I've used. I know it's pretty similar. Some of you might have done it. You might have actually used rainbow. I prefer doing the upside down rainbow, or you can call it the smiley face. Now, anytime you have a product like 30, very first thing we need to do is identify the two factors, the first two. The first factor is always 1. Because 1 always goes into a number, right? And so then on the other side, I'm going to leave a big gap. On the far right side is the number 30. And the reason I call this the upside down rainbow is because mainly I'm going to connect these two. 1 times 30 gives me 30, right? Now, if I was to ask you for every single product of 30, what might happen is you guys start randomly guessing. Okay, does 7 go in? Does 13 go in? What about 17? What about 27? What about 4? And you start going all over, and it's really hard. Do you have to check 30 numbers? No, to be honest, you're going to see how we're going to check, I think, 5 numbers on this one. The way we use this upside down rainbow is pretty simple. First, you have to set it up right. You set it up for the upside down rainbow. Second, we're going to use the number line. We started with the number 1. What is the next whole number? After 1 comes 2. Can 2 go into 30? Now, this is why I'm telling you guys to use your calculators if you're not strong in your math facts yet. I take my calculator, 30 divided by 2. Ooh, it does. 2 goes into 30 how many times? So, here's my number line, 2. But I don't want to write 15 right here. I got to go to the other side of 30, and I'm going to work backwards. So I put the first factor, and then I put the other one on the far right, and I draw the upside down rainbow. Do you see how my two lines never cross? It just gets smaller, kind of like a rainbow. Okay, what comes after the number 2? 3. So I could use my calculator and say 30 divided by 3 is 10. Oh, so is 3 a factor of 30? Yeah. 3 times 10. 3 times 10 is 30. After the number 3 comes the number 4. So 30 divided by 4 is 7.5. Do I use that if it's not a whole number? No. So 4 is not a factor of 30. How about after 4 comes the number 5. 5 times 6. There's 5. Here's 6. Upside down rainbow. 5 times 6 is 30. After the number 5 comes the number... Oh, wait. I already have that down. So, if the one that's going to match up has already been done, or if the one that is going to match up gets bigger than the one I'm already on, we know we're done. This is the halfway point. All my factor pairs now are just what do I connect with the rainbow? 1 and 30, 2 and 15, 3 and 10, 5 and 6. Those are all factor pairs. Make sense? So, with the infinity ball, Joseph, you missed this when you were not here the first day. This is the infinity ball. It's like Thanos' gauntlet all in one. If you drop it, you kill a planet somewhere in the world, in the universe. It's crazy. I know. So, oh, there goes one. Alright, so with the infinity ball, I want you to tell me what are some factor pairs of the number 20. So think in your head. Factor pairs of 20. I'm going to toss you the infinity ball, and I want you to give me one factor pair. I'll give you a huge hint. There are 1, 2, 3 factor pairs. Which one? It's okay. You can hit the desk. 1 times 20 is a factor pair. That was a low throw. You about killed planet Zubula. Now, when I say 1 times 20, do I have to say 20 times 1 is another factor pair? No. However, if they're asking me, like in this question, about the arrangement, if I did 1 row of 20 or 20 rows of 1, is that 2 different things? Absolutely. Think about it. What if I took all you guys' desks and I put us 1 row of 21? Or if I put 1 row, but I did 21 of them? That's different. It changes the view. Alright, so 1 times 20 is a factor pair.
Oh.
5 times 2 is 10. That's
Oh,
Andrew
I
shoot,
thought
Mr.
it was-
Sissel shoot. Factor pair of 20. 10 and 2. Alright, so I have 1 and 20 are factor pairs, 10 and 2 are factor pairs. Whoa, Grace killed the planet!
You killed the planet.
I threw it behind the back, no looker, and it scared her, and she killed planet Zubla.
Yay.
What's a factor pair?
5 times 4.
So 5 and 4 factor pairs. Any questions on factor pairs? How about this? I want you to tell me, what is my given number? I gotta write this down because I'm not smart enough. Okay. Hands up when you think you know what the given number is. What? Yes. What is it?
55.
Wrong. Now you owe me 10 hours of community service.
What?
Alright. One of the factor pairs are 3 and 5. What? 15 is my given number. Does he need to hear all the other factor pairs? No. 3 times 5 is 15. The other one was 115. Okay, let's see if you can get this one. One of the factor pairs are 2 and 9. One of the factor pairs are 3 and 6. And one of the factor pairs are 1 and 18.
Planet. You killed another planet.
You killed
Mr.
planet
Sissel.
Tutu.
Mr. Sissel.
Ah!
Who's
Planet Tutu the second.
How many planets are you killed today?
You guys are worse than Thanos and Snappy. Alright,
Thanos killed everybody. You were only killing planets.
we're keeping it down. Okay, what do you got? 18. Alright. Any questions what factor pairs are? Alright, so this is how we're going to use factor pairs. Let's move on. We're not really going to worry about the rest of that question. I want to go on to factor pairs. We don't really have to do this. Let's just write these down to help you because we did it with the infinity ball. You guys actually did a good job with infinity ball. So, when we list the factor pairs of 18, we said 1 and 18, 2 and 9, 3 and 6. I'm going to look at number 3. Now, most people will always get 1 and 51. What if I told you there's one other factor pair?
11 times 5.
Nope, 11 times 5 is 55. You're close though.
Is it 11?
Nope.
No. Okay.
Use your number line in your calculator. Use your number line in your calculator. Joseph? You think you know it?
Wait.
What?
3 and 17.
Joseph's got it. 3 and 17. Alright, those are factor pairs. Okay? I don't really feel like we're going to have troubles with that on our homework. So, let's turn the page. Oh, I better use part of this copy. Alright. We're going to go over this fairly quick. I do not think you'll have troubles with it. We did this very well in our exploration. Writing prime factorization. What is the prime factorization of 48? That is going to be one of your questions on your homework. It will say, what is the prime factorization of 48? Pay attention to tree number 1. The way they did it was they listed 48 down, and they listed 2 of the factors. Now remember, Is all you guys' work going to be exactly the same? No. Because you can list any factor pair. On tree 1, they used the factor pair 2 times 24. On tree 2, they used 13 and 16. I could have used 4 and 12. The only thing you cannot use is 1 and the number itself, because it doesn't do anything. Okay? So, if we look at tree 1, they did 2 times 24. When you get to a prime number, circle it. 24 is composite, so they broke it up to 2 and 12. 12, they broke that into 4 times 3. 3 is prime. 4 is composite. They broke it to 2 times 2. And then all you have to do, since I'm left with only primes, is the best thing to do is start with your smallest number, which is 2. And I have 1, if I even number these, 1, 2, 3, 4 of them. 1, 2, 3, 4. 2 times 2 times 2 times 2. And we had 1, 3. So they wrote 2 times 2 times 2 times 2 times 3. I want us to try it for the number 20. We're going to try this together. So everyone follow along, because I'm going to have you try one by yourself here in a second. 20 is not prime. Can anyone tell me a factor pair of 20? Andrew. Okay, 2 times 10. Everyone should write that down. Is the number 2 prime or composite? It's prime. Let's circle it. Is 10 prime or composite? If it's composite, raise your hand and tell me a factor pair of 10. Joseph. Okay, let's do 2 times 5. Is 2 prime or composite?
Prime.
Circle it. Is 5 prime or composite? Ooh, it's prime. Do I have anything to break down? No, I'm out of composite numbers. So my answer is 2 times 2 times 5. That is what you will write on your homework. Oh, and before I forget, when you do your homework on your computer, you do have to type it out this way. Do not use the X on your keyboard for your multiplication sign. It will say it's wrong because it reads it as a variable. So you have to go 2 and then you have to go click the multiplication sign, okay? Alright, let's do one more and see if you guys are good with this. 90. Can anyone identify a factor pair of 90? Grace.
9 and 10.
Sure. 9 times 10. Which is funny because I had 2 sets of number factor pairs in my head, and 9 times 10 was not one of them. Are we still going to get to the same answer? Yeah, it doesn't matter as long as we keep breaking them down. Is 9 prime or composite? Composite? So what can I break 9 into? What's a factor pair? Good. Prime. Prime. Am I done?
No.
Who can tell me why I'm not done? What haven't I heard much? Cohen, why am I not done, buddy?
Because 10 is a composite number.
Absolutely perfect, Cohen. Nice job. 10 is a composite number. What can I break it into, Brayson? 2 times 5. 2 is prime. Is 5 prime or composite? Prime. So I'm done? Am I done?
No. No.
Yeah.
Who's saying no? What do you think? Why am I not done?
You're not done because you have to go 2 times.
Oh, okay. So I have to write my answer. Okay. Yeah, so let's write my answer. 2 is my smallest number. 2 times 3 times 3 times 5. Alright, real quick. Fist in front of your chest. I need to know. A 3? Yeah, I totally get this. I get how to do it. I can do it on myself tonight for my homework. 2, I think I get it. If you would check in with me, I'd feel more better. 1, I'm pretty lost. I have no idea how to do prime factorization. 0 is, I thought this was reading class. Okay? So, go ahead and show me. When I point to you, you can put yours away because I don't need other people to see yours. Good, 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 good. Good. Good, 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 good. Good, 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 good. Alright, looks like for the most part we're really comfortable with this. I love it. This is why we practice. Okay, last example. When I did notes, we had extra examples. Don't worry about this. I want us to look at the one that says using a prime factorization. I'm not going to lie to you guys. This gets confusing. Okay? So I think there's 2 questions on your homework about this, so pay close attention. It says, I'm going to highlight this part. What is the greatest perfect square? Now, do you guys remember a perfect square from lesson 1?
Yeah, yes.
Not really. Yes.
So a perfect square was like the number 4, 9, 16, 25, 36. And remember, it's because I did a number times itself. 4 was 2 times 2. 9 was 3 times 3. 16 was 4 times 4. 25 was 5 times 5. 36 was 6 times 6. So 4, 9, 16, 25. Those are perfect squares. Remember, a perfect square is the product that has 2 numbers that are the same that multiplied or together, right? So number squared. This is saying in the number 1,575, what is one of the factors, if I listed all of its factor pairs, which would be a lot of them, if I listed all the factor pairs, what is the largest factor that is also a perfect square? Now, that'd be really hard to do. If I did the number, I'll do it on the board real fast. If we did the number 20, for example, that'd be kind of easy. My factor pairs are 1 times 20, 2 times 10, 4 times 5. Is 1 a perfect square? No. Is 20 a perfect square? No. Is 2? Is 10? Is 4?
Yes.
Is 5? So the largest perfect square is 4. That's not real hard. I only had 6 numbers to look at and to say, which one is a perfect square? And which one's the largest? 1,575? Oh boy. I don't want to list all its factors. So what we do is we use prime factorization. And all you're going to do is look at this one right here. And this is how they did it. They did the work for us. They showed us. The first factor pair they said was 25 times 63. Whew. You think we would have listed that right away? I wouldn't have. But 25 times 63, if you multiplied them, you get that. Now 25 is not a prime number, so we did the same rule. We broke it down to 5 times 5. 5 and 5 are prime numbers, so we circled them. 63, composite number, so they made it 7 times 9. 7 is prime, 9 is not. 9 broke down to 3 times 3, which those are prime. So I'm going to write this real big so you guys can see. So if you want to write bigger with me, I would too. I'm just going to copy this over here. The prime factorization of 1,575 was 3 times 3 times 5 times 5 times 7. That should be nothing new to you. We just did prime factorization. I'm just writing this bigger because I'm going to do a little work with it. But these are the prime numbers written in order. The 5, 5, 7, 3, 3. I just put them in order. Okay, here's my question. In order to find the greatest perfect square, I first have to look at these prime numbers. Can I square any numbers? Are any numbers repeated twice? Which number is repeated twice?
3 and 5.
Yeah, there's 2 3s, right? So either highlight the 2 3s or underline. And then I heard you say the other one. What was the other one?
5.
And we see 2 5s. Is the 7 repeated twice? So I don't care about the 7. We said it duck hunting. We just said, go away. Go play. We don't like you. You smell like cheese. So all I'm going to do is I'm going to say, okay, what is 3 times 3? 9. Times, what is 5 times 5? So I broke it down to 3 times 3 is 9. 5 times 9 is 25. And then 9 times 25, if I use my calculator, would give me 225. That is my answer. To find the greatest perfect square, step 1, do prime factorization and write it all the way down to your prime factors. Step 2, I would highlight or underline any numbers that are repeated. The 3s are repeated and the 5s are repeated. I'm then going to multiply those all together. You could have easily, instead of saying 3 times 3 is 9, 5 times 5 is 25, I could have taken my calculator and just said 3 times 3 times 5 times 5 equals 225. Now, 225 is a perfect square because 15 times 15. Does anyone see how we could have got 15 times 15? Since I had 2 numbers repeating, I had 2 3s, 2 5s. I would add a 3 times a 5 and a 3 times a 5. 15 times 15. Okay? I know that'll be a little tricky. Okay, I'm going to stop. I want you guys to work on your homework today. Listen. Your homework is due by Wednesday, 7:30 a.m. Lied to you. Thursday. I'm going to keep forgetting today's Tuesday. So it's due Thursday. When you come to class Thursday, you must bring your notebook. We're going to do lesson 1 through 3 review. We're going to set up our notebooks. We're going to set up OneNote. We're going to look at Schoology. And then we're going to do 3 reviews with 3 games. Okay? Now, I'm going to pop this in real quick. When you go to work on your homework, we still have 11 minutes to work on homework. First thing, on your paper, name, date, lesson, and then I'm going to add a 4th line. If you would, it'd just be helpful. I forget who came up with it, but they were genius. If you put 1S, because you guys are first block on a silver day. Okay, show all your work for me.